Hello, Bacho. Let's read this question. It says the important terms are used in magnetism are magnetic field induction, magnetic flux density or magnetic field strength measured in Tesla, magnetic intensity or magnetizing force H vector measured in ampere per meter, intensity of magnetization I vector is measured in ampere per meter, and the magnetic moment is measured in ampere meter square. The magnetic permeability is measured in Tesla meter per ampere. Magnetic permeability of free space is measured in Tesla meter per ampere. Relative magnetic permeability mu r, it has no units. Magnetic susceptibility chi m has no units, and the Faraday colleague classified the magnetic substances into three categories. First, the diamagnetic substances like antimony, bismuth, copper, gold, silver, quartz, water, alcohol, mercury, air, hydrogen, nitrogen, etc. Paramagnetic substances like sodium, potassium, aluminum, chromium, platinum, magnesium, manganese, lithium, etc. And the ferromagnetic substances like iron, cobalt, and nickel. Now, they are saying that the ferromagnetic substances show all the properties of paramagnetic substances, but to a much greater degree. And the paramagnetic substances are those in which each individual atom molecules and has same net magnetic moment of its own. When such substances are placed in an external magnetizing field, they get feebly magnetized in the direction of the field. Diamagnetic substances are those in which individual atoms, molecules, ions do not possess any net magnetic moment of their own. When such substances are placed in an external magnetic field, they get feebly magnetized in the direction opposite to the magnetizing field. According to the Curie's law in magnetism, the intensity of magnetization I of a magnetic material is directly proportional to the magnetic field induction B and inversely proportional to the temperature T. So I is directly proportional to B and I is inversely proportional to the temperature of T. So they just combine it. So I is going directly proportional to B upon T as B is directly proportional to H. So I is directly proportional to H upon T, and we can say that I upon H is going to be inversely proportional to B T. Because I upon H is going to be the chi m, so we have just put it that value here. So it becomes chi m is going to be C upon T, where C is the constant of proportionality and is called as the Curie constant. Now, for question number 38 to 46, two statements are given, one labeled as assertion and another labeled as reason. Select the correct answer of these questions from the codes A, B, C, and D as given below. The code A says both assertion and reason are true, and reason is the correct explanation of A. Code B says both assertion and reason are true, but reason is not the correct explanation of A. Code C says the assertion is true, but the reason is false, and code D says assertion is false, but the reason is true. So let's read the assertion and reason. Magnetic flux density represent number of magnetic field lines passing normally through unit area of the substance. This is also called magnetic field strength. And reason says magnetic field strength has also been defined in the terms of magnetic field lines in the same way. Look, what is the key concept we have? So the key concept is actually what? Magnetic flux density. So basically मैग्नेटिक फ्लक्स क्या होता है, वो होता है phi is going to be b dot area, और अगर मैं b को डिफाइन करूँ तो ये हो जाएगा phi upon a. Phi is actually the number of field lines passing from a particular area, and if area becomes 1, then b becomes magnetic flux density, which is the number of magnetic field lines passing from a particular area. This b is often called as magnetic field strength. Now what is the magnetic field strength for this region? So if we have to define the magnetic field strength, then magnetic field strength is basically, we can say, the measurement of intensity of the magnetic field, like how the magnetic field is intense at a particular point. So it's not defined in the terms of field lines, but it defined as what? Magnetic field strength was the intensity of magnetic field. So the assertion is true, but the reason is false. So if I just go with the codes, the code C is the perfect answer for this question. I hope you understand well. Best of luck. Thank you.